couple of days ago I had a request for a video about the exam questions for the core practicals, and it got me thinking that wouldn't be a bad idea. So I'm aiming to keep this video fairly short, but we're going to focus on the types of questions you might get linked to the core practicals. So to start, we're going to focus on two key words, two words that are really important when you're working like a scientist. The first of those keywords is valid. To make any experiment valid, you have to think about how you're going to control the variables. You should only be changing one thing, that's the independent variable. You should be measuring something, that's the dependent variable. But everything else that could affect your experiment should be controlled to make it a valid test. So think about, how will I control the control variables in this experiment? The other important part of being valid is having a good range of results. So you need to think, what range of results should I use to make this experiment valid? The second keyword is reliable. In all experiments, we're always aiming to repeat our readings until we have three concordant results, three results that are in line with each other. Then we remove any anomalies, any results that do not fit that pattern, and then we average our results by adding together our concordant results and dividing them by the number of results we have. Please remember, you cannot be more accurate than your original readings. If you measure something to 0.1, then when you average, you can't have an answer 0.15. It implies you're being more accurate than you actually measured it. Just one of my little bugbears. And accuracy is the last part of being reliable. You need to think, which piece of equipment should I use to be the most accurate? And so with those very important, basic, generic idea for any science practical, whether it be physics, chemistry or biology, let's have a look at some physics-specific examples. I'm going to first look at questions that are obviously core practical questions. I'm then going to look at some questions that are applications of core practical ideas, and I'm going to finish with a couple of examples of things that are core practical questions, but they're not so obviously a core practical question. To select my examples, I have chosen from the Year 10 exam and the 2018 papers. I've looked both at foundation and higher. There were lots of examples I could have picked. I have narrowed it down to two of each type. Two obviously core practical questions, two application of core practical ideas questions, and two not so obvious it's a core practical question. My first obvious example, I have picked question 2 from the P2 paper of 2018, that's on the higher paper, but it was also question 8 on the foundation paper as well. So this question is testing you can remember the method for the core practical. It's checking you can think about how to do anything that will make it a more valid experiment. And then there's the little bit to really make sure you're thinking about what's actually happening in the experiment at the end. But a straightforward core practical question. You'll notice that I'm not going through each question now specifically. What I'm trying to do is show you the different types of questions. The best way to get good at this is practice. Use the past papers. There are sample papers out there. There's the Year 10 exam paper. There's the 2018 papers from last year. Use those examples. Try questions. Learn from your mistakes. Use the mark scheme to go back and go over your work and learn from the errors you've made. The exam reports also have some really good tips in them. So download them, use them and practice. So this next example of an obvious core practical question comes from the Year 10 exam. It was question 1 on the higher paper and question 3 on the foundation. It's looking for a method again. It wants to see how you're going to make it valid. It wants to see that range of results that you're going to look at and the repeats that you're going to do. Then it's checking that you can identify anomalous results and explain why they're anomalous. So from two examples where it's obvious they're a core practical question, they're about exact core practicals that you've done, we go to something that isn't a core practical that you've done, but uses the ideas of core practicals, of testing like a scientist. This example is from the foundation paper of P2 from 2018, and it was question 9. Now, it's obviously testing the ideas of work done and power, but it's also trying to test your ideas of how to make your experiment valid, what readings you would take, and also how to make your experiment reliable. For example, how accurately, what apparatus you'd use to take those results. So it's kind of a core practical question too. And this one is from the higher paper last year, 2018, P2 question 5. It's also not a direct core practical question. It's a question about induced current. But it's also linked to Hooke's law and the core practical for springs. So it's also looking at how are you going to make this experiment valid and reliable. It's all in there when you check the mark scheme. And then there are those little tricky questions that aren't obviously core practical at all. This one here is really the ripple tank experiment, and it was from the year 10 exam on the higher paper. It was question 2, right at the end of question 2. In this question, they're asking you, how are you going to do this more accurately? That's what they're asking. And so it's about accuracy and how you would do a method. Just like in the core practical on the ripple tank, how we would do it more accurately when we're counting the waves. And to the last example, the last not so obvious, it's really a core practical question. In this last part of question 2 on the higher paper of May 2018, P1, and also question 8 in P1 on the foundation paper last year too, same question. It's all about how would you make this more valid? How would you make this more reliable? That's what it's asking. This brings us to the end. Not the end for you, because you really need to go and practice. Like I've said, sample papers are out there, the year 10 exam is out there, the 2018 papers are out there, the mark schemes, the exam reports, they're all available for you to use. I chose just 6 little examples. I found many more just by looking at the 2018 and the year 10 exam papers. Have a practice. Push yourself to try first without any notes, then using the mark scheme, see what you can do to improve and learn from your mistakes. And then, on the day, whatever core practical they throw at you, whether it's obvious or whether it's an application of core practical ideas or whether it's a sneaky one that's not quite so clear, you'll be ready for it and you'll nail it. Regular review gets a better grade for you. Regular review gets a better grade for you. Don't forget to like, so that I can keep making the videos.
Comment.
Especially to request other revision topics.
Subscribe.
So you can get notifications of when my next video gets uploaded.